All right, more limits problems. On number 43, we're evaluating the limit at 0, and then at 2, and then answering a couple of additional questions. So this is what's going on at 0. We can see where x is less than 0, our function is x squared plus 2. Where x is equal to 0, our function is f of x equals 1. And where x is greater than 0, x squared, our function is x squared minus 2. So we're going to use this for part D, for the limit as x approaches 0 from the left of f of x. And we're going to use this part for part A, limit as x approaches 0 from the right. And this part in the middle, f of 0, is 1. So when x is 0, y is 1. That's what that part fills in. So let's go ahead and go in order. Let's do part A, the limit as x approaches 0 from the right. That means we're going to put 0 in for our x. So this would be 0 squared minus 2 is a negative 2. So part A is equal to negative 2. For part B, we're going to do x squared plus 2. So put in our 0 squared plus 2. So our function is positive 2 there. And so you can see that this function is not continuous at x equals 0 because our limit from the left and our limit from the right and our actual value f of 0, these three do not match. So our function is not continuous. So that actually answers part E. Where is f of x discontinuous? It's discontinuous at x equals 0. Because the limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right. And that also shows neither of those equals f of 0. All right. Let's go ahead and evaluate the limit as x approaches 2. So since 2 is greater than 0, we're going to use x squared plus 2 again. So here we would put 2 in. So that would be 4 minus 2, which is 2. All right, part E. If a function is discontinuous at x equals a, does it necessarily mean that the limit does not exist? And that answer is no. The limit could exist, but your value of the function could be different. So the limit could exist, but not match. F of x. So in that case, f of x would not equal that output. All right, that's number 43. Next one, number 44. Now, this is just kind of a smattering of multiple choice problems. A couple of them are limits problems, because I think that's great to have extra practice with always. Some of them are just good graphic problems or logarithm problems that I found that I thought were really good multiple choice extra practice. So this one is a limit problem or a discontinuity problem. I thought we could look at it. So we have a piecewise function, and we're asked about f of x equals negative 2. So let's pull out the pieces of this that actually have to do with negative 2. So we have x squared from negative 2 to 2. So that's one side of the limit. And the other side is here. I see another negative 2, so we're going to use that one. So 5 for x is less than negative 2. So what this would look like if you were thinking about sketch here. At -2 is where you would have kind of this breaking point of your function. And to the left, where x is less than or equal to -2, your function would be up at 5. You guys know how terribly ours is pronounced. And to the right of there, well, from -2 to 2, not including our endpoint, we have the picture, our function is x squared. And you guys know what x squared looks like. We can do this graphically. So we'd go over 1, up 1, over 2, up 4. And we would have an open circle there. And that would be the same on the other side of our y-axis here. This is where our parent functions are really helpful. If you can think about, if you can think about what the parent function looks like, I think on this one it saves you some time actually evaluating the function. So here, as we evaluate from the left, our function is going to 5. From the right, our function is going to 4. So there is a discontinuity, and it's not removable because we're not just like plucking out that one little point. It's actually a jump discontinuity. And again, a jump discontinuity is just what it sounds like. The function has to jump to get to that next line or get to the next square. You can evaluate the function. You would say, okay, the limit as x approaches -2 from the left, and there we would use 5 of f of x is 5, and that's just from the definition there. And then the limit as x approaches -2 from the right of f of x is, well, we would need to plug into our x squared function, so we would do -2 squared and positive 4. And since 5 and 4 are not equal, definitely not continuous, and since 5 and 4, there's a jump in between them, it's a jump discontinuity. Great. We'll do a couple more problems on this video. Which of the following functions could have the graph shown? All right, so this looks like an exponential to me, and all of our options are exponentials here. And it's an exponential that's flipped. So again, thinking about our parent functions, our normal exponential function looks like this. So it has a y-intercept of 0, 1. It has a horizontal asymptote at y equals 0. And it's increasing. So to flip it around so that it's decreasing, that's going to be a reflection over the y-axis. And to reflect over y, we need that negative to not be on the outside of the function, but to be on the inside. And to be on the inside of the function here, that means that it's up in the exponent. So e to the negative x. So we can get rid of ln. We know ln is a totally different shape than this. And we can get rid of the option A, which doesn't have that negative outcome. The other thing that's happened once this is flipped around is that this asymptote has moved up. It's usually at 0, so it's moved up 1. And to do up 1, we have that +1 on the outside of our function, so it would not be in the exponent. So that makes this one B. All right. One more logarithm problem. Find all values of x such that ln of x minus ln of 1 over x equals 4. So, log rules, I know they're your favorite. What we need to remember first here is minus means divide in log world. So we need to condense, and we're going to condense these using division. So this is going to be ln of x divided by 1 over x. And if you would rather write that, an alternate way of writing that would be this. And I like that. I think that the second way I wrote it here is probably more consistent with what we did in class. I also, since I have a complex fraction already, would probably in either case make that just x over 1, so I have a fraction. So if you like the first way I wrote it, you're probably thinking flip the second and multiply. If you like the second way that I wrote this, you're probably thinking we will group these, which is absolutely correct. But before we do that, let's go ahead and get rid of our logarithm. So the way to get rid of our logarithm is to use the exponential form. Since we don't have a log on each side of the equation, we can't just cancel our logarithms. There's nothing to cancel on the other side. And when we're solving an equation, we have to do the same thing for each side. Instead, we're going to use the exponential e to the 4th equals the mess in our parentheses. And however you like writing it, bring down either one of these options, whichever one you like. And then I'm going to group here. You can flip the second and multiply if you like that other option. X times x over 1 times 1. And x times x is x squared. So we have x squared over 1. And then to solve for x, we just need to take the square root of both sides. So e squared equals x. You can also plug in that value and test. Put e squared here and e squared here, and make sure when you put this in your calculator that it is equal to 4. Lovely. Very close to the end of the exam.